Hello children, today we will be doing exercise 2A from the topic of exponents. So let's begin with our first question, that is question 5, which says simplify x raised to a plus b the whole raised to a minus b into the small dot is multiplication x raised to b minus b plus c the whole raised to b minus c into x raised to c plus a the whole raised to c minus a. So children, you have learnt the topic of identities. One of the identities is if we have a plus b multiplied by a minus b, that is equal to a square minus b square. And here we can see we have a plus b multiplied by a minus b. So instead of writing a plus b and a minus b, when we multiply, we can directly make the power as a square minus b square. Similar thing we can work upon here also, assuming this b to be our a and the c to be our b. We can apply this identity for this multiplication as well as multiplication of the c plus a into c minus a also. So let's begin with it. Please remember this identity. It is an important one. Let's continue. Here we say that is equal to x raised to a square minus b square. I hope you understood how we are getting this, multiplied by x raised to b square minus c square multiplied by x raised to c square minus a square. Now, the next step is when we have a common base, what do we do with our identities? When we have a common base, what do we do with our exponents? When the common bases are multiplying, we add the exponents. And that's what we are going to do here. X raised to a square minus b square plus b square minus c square plus c square minus a square. Now if you notice over here, this a square is a positive one, will get cut by the a square negative. Minus b square plus b square, again 0. Minus c square plus c square, again 0. So what's left to the power of x? We have x raised to 0, which in turn is equal to 1. Any base raised to the power of 0 is equal to 1. I hope you understood. Let's move to the next question, which is question number 6. We have a sub question over here that says root of x raised to 20 minus, it's not a minus, we have directly y raised to minus 10 and z raised to 5, and the root has a 5 over here, divided by x raised to 3 upon y raised to 3. So what are we going to do here? First of all, let me remind you that in case of a root sign, this is the identity over here. If I have a 4 over here and a over here, we get that is equal to a raised to 1 upon 4. Okay, so the similar law we are going to apply over here. We will say that is equal to root of x raised to 20 y raised to minus 10. Excuse me. Sometimes I do act silly. I'm making the videos, I'm not very used to it, probably for that reason. Obviously the root sign vanishes. So here we will have x raised to 20 y raised to minus 10 and z raised to 5, this whole raised to 1 upon 5. Just like here. Here there was only one term, so we didn't make a bracket, but here there are 3, so that is why we are making a bracket. This whole raised to 5, 1 upon 5, divided by x cube upon y cube. This does not change at all. This is further equal to, now again another law coming into picture where we have a into b, the whole raised to 2 will be equal to a raised to 2 into b raised to 2. This 2 will be applicable to both a and b. Similarly, this 1 upon 5 will also applicable to each term in the bracket. So we will say x raised to 20 multiplied by 1 upon 5 into y raised to minus 10 into 1 upon 5 into z raised to 5 into 1 upon 5. The whole divided by x raised to 3 upon y raised to 3. Children, I hope you are clear with this law and you've understood how we are applying these laws simultaneously over here. Let's move further. This will give us over here, if you notice, we will have 5 1 times, 5 4 times, 5 1 times, 5 2 times, and because it's a negative 10, we will have minus 2 over here, and here 5 5 both get cancelled. So we have that is equal to x raised to 4 into y raised to minus 2 into z raised to nothing but 1, which we need not write, divided by x raised to 3 upon y raised to 3. Now this, when we are doing, we are dividing this whole term with here. So what happens when we have common bases and division happening? We subtract our powers. Let me just show you over here. For instance, if I have x raised to 5 divided by x raised to 2, I will have x raised to 5 minus 2. That's equal to x raised to 3. So similarly, I will have over here, we will do that is equal to x raised to 4 into y raised to minus 2 into z. When we have a fraction division, we first convert it to multiplication. Reciprocal ho jayega, y raised to 3 and x raised to 3. Now we will apply this law which we have just recapped, and we will say that is equal to, that's equal to x raised to 4, this x and this x both are in division terms, so we will be subtracting the powers, into y raised to minus 2, again same basis y. Here they are multiplying, so this 3 will be added and our poor little z is left alone, doesn't have any partner. Never mind. It's going to enjoy its own company. That is equal to x raised to 4 minus 3 is 1 into y raised to minus 2 plus 3. Again that is y raised to 1, and our little z was already by itself. This is the answer. That means I think everybody wanted to be alone like z. They were enjoying their company. So here we have x, y and z, all the three enjoying each other's company. Okay, that's our final answer. Moving ahead to the next sub question, the second one. Here we have some numbers to deal with. We have 256 upon 81 and 256 a raised to 16 upon 81 b raised to 4. This whole raised to minus 3 upon 4. This really looks a little weird, but trust me, it's very, very simple. So let's see how it is simple. Now children, whenever you have such a big base, 256, 81, please try to simplify them and bring them to the lowest possible base. And when you have a fractional power, try to have this base with similar power as this denominator, because that will make your simplification easy, like we did over here. Like over here we simplified 5 and 20 because they had common factors. The simplification went very easy. So we will always try to have our simplification in such common factors. So that is possible, only we have a friendly power over here. So let's see how we'll do it. Now 256, 8th graders, I'm sure you should learn your powers, your cubes and squares. So if you've learned it well, you will know 16 square is equal to 256. Now when you have 16 square as 256, let us make, 16 is also a square of something. Yes, if you've said 4, you're absolutely right. So I can say 4 square, the whole square. That in turn will give me 4 raised to, remember the product law, 2 multiplied by 2, we will have 4 raised to 4. So, and here is the 4 which I was looking for. So this at 256, I am going to write as 4 raised to 4. Similarly, even 81, we can try and make for that. We know 81, we know, what do we know over here? We know 27, yes. 27 raised to, no, not 27. I know that 9 square is 81, yes. I know that 9 square is equals to 81. And I also know that 9 is also a square of some number, yes. 3 raised to 2 raised to 2. 3 ka square is 9 and uska square is 81. So here again we get 3 raised to 4. So again this 81 I am going to represent as 3 raised to 4. So let's see how we will go about it. We have 4 raised to 4 a raised to 16 upon 4 raised to, not 4, 3 raised to 4 and b raised to 4. This whole raised to minus 3 upon 4. Now, what happens over here? We say that's equal to, remember this power is applicable individually to these terms. So we will have that's equal to a raised to 4 multiplied by minus 3 raised to 4 into, silly me, this was not a, this was 4. Here we have 4 into a raised to 16, the whole rate multiplied by minus 3 raised to 3 upon 4. Similarly, I will come over here, this whole thing upon 3 raised to 4 into minus 3 upon 4 into b raised to 4 into minus 3 upon 4. Now we can do our simplification. We say 4 and 4 got cut. 4 1 times, 4 4 times, 4 4 cut, 4 4 cut. So we have, what do we have here? We have, where is my cursor? Yep. We have that is equal to 4 raised to minus 3 into a raised to 4 into minus 3 will give me minus 12 upon, I will have 3 raised to minus 3 into b raised to minus 3. Now children, if you remember, whenever we have negative powers and we want to eliminate them or we want to escape them, what do? We do the reciprocal of our terms. So here what will happen? We are going to flip this fraction upside down and we will have 3 raised to 3 b raised to 3 upon 4 raised to 3 a raised to 12. So all the powers are now positive and we have flipped our fraction. So let's do the final working. The answer 3 raised to 3 is 27 and 4 raised to 3 is 64. This raised to b raised to 3 upon a raised to 12. This we can also write as, in case if you wish, you can also write it as 27 upon 64 a raised to minus 12 and b raised to 3. Okay, we can also write it as this. Both the answers are right. Absolutely right. Let's move to the next question. The next question is question number 7. It says, simplify. Again, we have two sub questions over here. The first sub question says a raised to minus 2 the whole a raised to minus 2 into b and the whole raised to minus 2 multiplied by ab the whole raised to minus 3. Now what happens over here? Here we get that is equal to, we are going to multiply this minus 2 individually to each term. So we have a raised to minus 2 into minus 2 and b raised to minus 2 multiplied by a raised to minus 3 into b raised to minus 3. Now here we have common bases. If you notice, I have common bases over here, AA and BB. So we will bring the common bases together. We will have, that is e raised equal to a raised to, this minus 2 will become plus 4. Okay, so we have here 4 and this minus 3 into b raised to minus 2 minus 3. So I have, that is equal to, that's equal to a raised to 1 into b raised to minus 5, which I can further write as, that's equal to a upon b raised to 5. My base becomes positive. Okay, this was simple. Let's move ahead to the next sub question. Here we have x raised to n, x raised to n into y raised to minus m the whole raised to 4 multiplied by x raised to 3 y raised to minus 2 and the whole raised to minus n. Let's see how we go about this. That's equal to, multiply this 4 with each of the inside terms. We will have x raised to 4n into y raised to minus 4m into x raised to 3n into y raised to n, because this minus 2 multiplied by minus n will give me only n. That's equal to, now let's bring the common bases together. We have x raised to 4n plus 3n into y raised to minus 4m plus n. That's equal to x raised to 7n into y raised to minus 4m plus n, because we can't add these two. That's equal to x raised to n y raised to minus 4m plus n. Let's move ahead to the next question, the third one. It says 32 x raised to minus 5 upon 243 y raised to minus 5 the whole raised to minus 1 upon 5. I'm sorry children, this is the fourth sum. This is not the third sum. This is the fourth sum. I will do the third sum later. Let's continue with this as the fourth sum. Reading the textbook simultaneously, it's a little difficult task. That's equal to 32. Again, I told you in the previous sum, when we have big numbers, please try to bring them at a smaller base. Let's write them into exponential form. Now we know 32. We know that we have 2 raised to 5 as 32. And we also know that we have 3 raised to 5 as 32. In case you're wondering how should you get this, you can do your prime factorization method, and with that you can surely get that. X raised to, 1 minute, we write it neatly, 2 raised to 5 and x raised to minus 5 upon 3 raised to 5 into y raised to minus 5, the whole raised to minus 1 upon 5. And prime factorization method, a quick recap of that: 32, 2 into 16, 2 into 4, 2 into 8, 2 into 4, 2 into 2, 2 into 1. So here we have 1, 2, 3, 4, 5 2's. So we have 2 raised to 5. Okay. I hope you're clear with this. Now moving ahead to the next step. That's equal to, now here we will multiply this 1 upon 5 to each of these terms. So we will get 3, we'll have 2 raised to 5 multiplied by minus 1 upon 5 into x raised to minus 5 into minus 1 upon 5 upon 3 raised to 5 into minus 1 upon 5 into y raised to minus 5 into minus 1 upon 5. Bracket is not really required over here. That's equal to, let's do the cancellation. We have 5 1 times, 5 1 times, 5 1 times, 5 1 times. This is a minus 1 over here, remember. 5 1 times, 5 1 times, 5 1 times, 5 1 times. Now what happens really over here is, we have, that is equal to 2 raised to minus 1 into x raised to, now this minus minus becomes plus, so we have a positive x over here, upon 3 raised to minus 1 upon y raised to, what do we have over here? Y raised to, again minus minus, we have plus 1. That is further equal to, we say that is equal to, now this minus minus we want to bring reciprocal, so we will say, we will put this, flip this upside down, we will say 3 upon 2, and the x and y, they have positive powers, so they remain as it is. Their place does not change. Only the numbers with negative powers will be flipping. Okay, so this is my final answer. Moving ahead to the third sum. I should be saying moving backward, right? Not ahead actually, because we are actually literally going backward. So let's move backward to the third sum, which is third one. What was the sum which I skipped? 125 a raised to minus 125 a raised to minus 3 upon y raised to 6 the whole raised to minus 1 upon 3. Now children, remember this minus 3 is only to the a sign. It is not applicable to 125. So let us make this 125 also into exponential form, which will be 5 raised to 3 into a raised to minus 3 upon y raised to 6 the whole raised to minus 1 upon 3. Here, remember what we are going to do? We will multiply this fraction to the individual terms. So we have 5 raised to 3 into minus 1 upon 3 and a raised to minus 3 into minus 1 upon 3 upon y raised to 6 into minus 1 upon 3. Let's do our simplification part. 3, 3 gone, 3, 3 gone, 3 one times, 3 two times. So here we have, what do we have here? We have that's equal to, I'll just clear this much space. We have that's equal to 5 raised to 1 minus 1 upon, a raised to plus 1 upon y raised to minus 2. Now these two have a negative power, so we are going to flip it upside down and we can say that's equal to a, and here comes y also will come up, a y raised to 2 upon 5. Now you write that raised to 1 or you don't write, it's your choice. Moving ahead to the next question, which is, let's see what is the next question over here. Now we'll be doing the fifth one. It says a raised to minus 2, into b, the whole raised to 1 upon 2 multiplied by ab raised to minus 3. Now remember this minus 3 is raised only to b, it's not to a, the whole raised to 1 upon 3. Let's see what happens over here. That is equal to, multiplying this outside with the individual terms, we have a raised to minus 2 into 1 upon 2 and b raised to 1 upon 2 multiplied by a raised to minus 3 into 1 upon 3 into b raised to minus 3 into 1 upon 3. Now what happens here? We do the simplification and we have the 2 gone, the 3 gone, and the 3. This 3 is not going anywhere because there was no 3 over here into existence. I don't know how I brought it. Sometimes I really act silly. Maybe teachers are also human beings after all. So what do we have here left? We have that is equal to a raised to, nothing is left, 1 into b raised to 1 upon 2 into a raised to, here I have 1 upon 3, remember this 3 is not cancelled with anything, into b raised to 1. Now why I wrote this 1 this time? Because here we have common bases and we will be dealing with them. So we will have, this is minus 1 over here, okay. What we will have here, we will have that is equal to a raised to minus 1 plus 1 upon 3 into b raised to 1 upon 2 minus 1. That's equal to, moving down, That's equal to, now here remember children, what do? We bring our LCM into picture. So this will be a raised to minus 3 plus 1 upon 3 into b raised to 1 minus 2 upon 2. Okay. So here I will get that is equal to minus 3 plus 1, I get a raised to minus 2 upon 3 into b raised to minus 1 upon 2. Further, to write this into positive powers, I can say that's equal to 1 upon, make that 1 a little more into center, 1 upon a raised to 2 upon 3 into b raised to 1 upon 2. So my powers are positive. Moving ahead to the next sub question, which is the sixth one. Okay, that's equal to xy raised to m minus n into y raised to yz raised to n minus 1, all are in pairs, into n minus l, this is, into xz raised to l minus m. Now what are we going to do here? We are going to apply these powers individually to each term inside the bracket. So we'll have x raised to m minus n into y raised to m minus n into y raised to n minus l into z raised to n minus l into x raised to l minus m into z raised to l minus m. You know, I could actually sing this, but I literally sang it, I feel. अच्छा खासा गाना बना देते हैं maths में. Okay. Jokes apart, let's come here. What are we going to do here? We have common bases. So what are we going to do with a common basis? We are going to add their powers. So let's add the powers. X raised to m minus n plus l minus m into y raised to m minus n plus n minus l into z raised to n minus l into plus, not into, l minus n. Now what's happening over here? Here goes the magic. M cancels. N cancelled. L cancelled. Now I dramatized it a little, but I hope you understood. Positive m, negative m, positive n, positive l, negative l. Those were the ones that I cancelled. It wasn't just all drama. कुछ काम का काम भी किया है हमने. That is equal to x raised to, what is left over here? L minus n into y raised to m minus l into z raised to, what is left over here? Now here I have n minus m. Okay, so this is my final answer. Moving ahead to the next question. Ta-da! What's the next question? Oh, finally we finished question number 7. We are heading to question number 8, which has, they want us to do a show. Show that. Okay. मैं अभी इतना ड्रामा किया, अभी शो भी करेंगे. What is this? X raised to a. Let's write x raised to a upon x raised to minus b, the whole raised to raised to, what was I saying, a minus b. So I have a minus b into x raised to p upon x raised to minus c the whole raised to b minus c into x raised to c upon x raised to minus a the whole raised to c minus a. Children, remember when we have common bases and there is division, what do? We subtract the terms. So even here we are going to do the same thing. That is equal to, we will say x raised to a minus, what was the power over here? Minus b the whole raised to a minus b into x raised to b minus c the whole raised to b minus c into x raised to c minus a the whole raised to c minus a. Now what happens over here? Minus minus becomes plus. So we have x raised to a plus b the whole raised to a minus b into x raised to b plus c the whole raised to b minus c into x raised to c plus a the whole raised to c minus a. Now remember, in the beginning of the video I had told you about an identity which said a plus b into a minus b is equals to a square minus b square. That is exactly what we are going to do. We will say that is equal to x raised to a plus b into a minus b is equals to a square minus b square into x raised to b plus b into b minus c gives us b square minus c square into x raised to c plus a into c minus a gives me c square minus a square. Now what do? When we have common bases, we add our powers. So we have x raised to a square minus b square plus b square minus c square plus c square minus a square, that is equal to, let the battle begin, a square and minus a square, minus b square and plus b square, minus c square and plus c square, all have gone and become what? That has become x raised to 0, which ultimately leads to the power of 1. Any number raised to the power of 0 is equal to 1. So here is our answer. Let's move ahead. And by the way, here they told us to show us. So we say that is equal to RHS. The right hand side was this, and we can say hence proved. If you want, you can write over here. Hence, don't make a bracket. You can say dot dot dot. Hence proved. Okay. So let's move ahead to the next sub question. Agla padhao. What is this agla padhao, Baba? Let us see question number 9. Thankfully, no sub questions, but evaluate. So what do we have here? X raised to 5 plus n into x raised to 2 the whole raised to 3n minus 9 plus 1 upon x raised to 7n minus 2. The one who come for my tuitions must be knowing I usually tell them better dictate me the sum. Because looking down and then looking on the screen is a little complicated. That's why I'm not used to it, and sometimes I'm writing wrong sums. Let's move ahead. Here we have x raised to 5 plus n. भैया आपका कुछ नहीं हो सकता. We will write you as it is. But here we can multiply them. So we will have x raised to 2 multiplied by 3n, that is 6n, plus 2 into 1 is 2. So here we have done. Again, Mr. Denominator, आपका फिलहाल कुछ नहीं हो सकता. 7n minus 2. Now here in the numerator, oh, not 7, this is x. Huh? Okay. If you notice, we have all the numerators and denominators all have common base. So yes, अब भैया हम सबका कुछ ना कुछ करेंगे. What are we going to do? We are going to say x raised to 5 plus n plus, we will add this term 6n plus 2, and since this base is minus, we will subtract its term. For a safer side, write it into bracket. So ये पूरा term we are subtracting, so we will write it into bracket and we will say that is equal to, what is it equal to? That's equal to x raised to 5n, 5 plus n, right? Yes, 5 plus n into, no, plus 6n plus 2 minus 7n, and minus minus becomes plus, plus 2. That is equal to, now let's see, x raised to 5 plus 2, 7, 7 plus 2, I have 9, and n plus 6n will give me 7n, and 7n minus 7n will give me zeros. So n के family से तो कोई बचा ही नहीं बाबा. Here we have my final answer as x raised to 9. Let's move ahead to the next quest. What do we have here? We have the 10th question, and thankfully even that is only one question. You know how happy I feel when there is no sub-question. Seriously, I know the feeling is mutual. When you guys don't want sub-questions in between. Let's see, what is it saying? A raised to 2n plus 1 into a raised to 2n plus 1 into 2n minus 1. क्या हो रहा है ये? This is the identity a plus b into a minus b. The whole upon, what is it? A raised to n into 4n minus 1, the whole into a raised to 2, the whole raised to 2n plus 3. Yes. Now what do we do? Here the upper portion, the numerator, we very clearly know there is an identity hiding over there. So we will say that is equal to a raised to 2n plus 1 into a raised to 2n square minus 1 square. You see, a plus b into a minus b is equals to a square minus b square upon a raised to n into 4n will give me 4n square minus n into, what is coming forth, a raised to 2 into 2n is 4n, 2 into 3 is plus 6. So we have 2n plus 6 over here, 4n plus 6. That is equal to, what is that equal to? We have, let us see, we can furthermore expand this as a raised to 2n plus 1 into a raised to 4n square, okay, 4n square minus 1 upon a raised to 4n square minus n into a raised to 4n plus 6. Let's move ahead. What is happening next is, what's happening next? We have that is equal to common bases. Let's put them into use. We have a raised to 2n plus 1 plus 4n square minus 1. Now this plus 1 and minus 1 will both get cut off upon a raised to 4n square minus n plus 4n plus 6. Now here there is minus 4n, plus 4n and minus n. That can be done with something. We will have that's equal to. Now this entire term, this entire denominator, if you see, we have again common basis. So this entire power of the denominator we are going to subtract. So we will say a raised to 2n plus 4n square. This whole thing we are going to subtract from minus 4n square minus n plus 4n will give me 3n plus 3n plus 6. Children, please always write it into bracket. That is equal to a raised to 2n plus 4n square minus 4n square minus 3n. All the signs you see are changing now. So here we have, what do we have left over here? Let's begin the battle. 4n cancel, and we have left is a raised to 2n minus 3n will give me only 1n left, which is a negative 1, and minus 6. This, since the powers are negative, we will write it as that is equal to, what is it equal to? A will go down, mister. 1 upon a raised to n minus 6. Not n minus 6, this will become n plus 6. How will this become n plus 6? Because it's coming as reciprocal. So ये n plus 6 हो जाएगा. Okay? चलो. Moving ahead to the next sub question. Okay. The next main question, not the sub question, which is question number 11. Again, they want a proof. They are asking us to prove something. So let's see what are they asking us to prove. M plus n, the whole raised to minus 1, into m raised to minus 1 plus n raised to minus 1 is equal to mn, the whole raised to minus 1. We have to prove this. Okay. Now, how are we going to prove it? We will first start with our left hand side. We will say LHS is equal to, what is the LHS equal to? M plus n, the whole raised to minus 1 into m raised to minus 1 plus n raised to minus 1. This is further equal to, we will, since the powers are negative, we are going to make reciprocal 1 upon m plus n into, we will have here 1 upon m plus 1 upon n. Now children, imagine if you had 1 upon 5 plus 1 upon 2. How would you do it? Since they are unlike fraction, you would have said LCM liya hota. What is the LCM? 5 multiplied by 2. So yes, my LCM would be 10. 5 multiplied by 2, that is 10. And what would I have here as my numerator? 1 multiplied by 2 plus 5 multiplied by 1, that is 5. Similarly, over here also, what we are going to do is, we will take the LCM and we will say, this will remain as it is. Over here we will say, m and n ka LCM kya hoga? The product of mn, and here we will say n plus m. Okay, n plus m bolo ya m plus n bolo, the same thing. Now what happens when we open our brackets? We get that is equal to 1 upon m plus n into m plus n upon mn. Now m plus n or n plus n means the same. What happens? We can simplify, we can cut off these two, and what is left is that is equal to 1 upon mn. Now, how can we write this? Since it's a denominator form, we can write it as mn the whole raised to minus 1. And let me recollect what is our right hand side. Oh yes, ये तो बिछड़े हुए भाई निकले. M raised to minus 1 and mn raised to minus 1. So we can proudly say this is equal to RHS and hence proved or proven, whatever. So let's move ahead to the next sub question. Not sub question, main question only. Even before I said sub question. Prove that. My God, they were so happy with our proving. They gave us one more proof. Let us see what is it saying. Question 12. It says x raised to a upon x raised to b the whole raised to 1 upon ab into x raised to b upon x raised to c the whole raised to 1 upon bc into x raised to c upon x raised to a the whole raised to 1 upon ca is equal to 1. Okay, so now we'll say, let's begin with the right hand side. We'll say RHS. Not right hand side. How silly. Right hand side तो 1 है. 1 से क्या शुरू करेंगे हम? 1, 2, 3. No, we'll say LHS is equal to x raised to a upon x raised to b the whole raised to 1 upon ab into x raised to b upon x raised to c into the whole raised to b upon c 1 upon bc into x raised to c upon x raised to a the whole raised to 1 upon ca. Now what do? We will multiply this outside power with the inside power. So let the fusion begin. We will have that is equal to x raised to a into 1 upon ab upon x raised to b into 1 upon ab into x raised to b into 1 upon bc upon x raised to c into 1 upon bc into x raised to c into 1 upon ca upon x raised to a into 1 upon ca. Now the fun part begins. A gone, B gone, B gone, C gone, C gone, A gone. So what do we have left over here? If most of it is gone, so what is left? We have that is equal to x raised to 1 upon b upon x raised to 1 upon a multiplied by x raised to 1 upon c upon x raised to 1 upon b into x raised to 1 upon a upon x raised to 1 upon c. Now children, all these terms are multiplying, and you know multiplication में भी simplification होता है. X raised to 1 upon b and x raised to 1 upon b 1 times x raised to 1 upon c, x raised to 1 upon c 1 time x raised to 1 upon a and x raised to 1 upon a. So what is left over here? 1 into 1 into 1 upon 1 into 1 into 1, it is equal to 1, and that is exactly equal to my RHS, which we can proudly say as hence proved. Okay, let's move ahead to the next sub-question. Oh my god, we have a sub-question here. Seriously. Chalo. What is the sub-question saying? Sub-question. Yeah, one more proving. 1 upon 1 plus x raised to a minus b plus 1 upon 1 plus x raised to b minus a is equal to 1. Now this they want us to prove. So let's start. We say our L, H, we say our, what are, we are saying, we say R, L, H, S, R matlab hamara LHS is equal to 1 upon 1 plus x raised to a minus b plus 1 upon 1 plus x raised to b minus a is equal to, no, not is equal to, I was about to copy down the entire thing again. Okay, now here children, if you see laws of exponents, they work when? They work only when we have common bases. And यहाँ पे हमारे पास common base नहीं है, but it is like, you know, on the other side of the river we can say. Plus sign is there in between. So we can't deal over here. So what we do is, instead, we want a common base on our side. So we will say 1 upon x raised to a minus a. Now why a minus a? Because if you see a minus a is nothing, 0. And x raised to 0 is equals to 1. So that is why we are saying a minus a plus x raised to a minus b plus 1 upon, again, here we will say x raised to, what are we going to say over here? Think, yes, you're right, x raised to b minus b plus x raised to b minus a. The same logic that x raised to b minus b will be x raised to 0, that's equal to 1. Further we say that is equal to 1 upon, now children try to understand what happens over here. We will split our bases. We will say x raised to a into x raised to minus a plus x raised to a into x raised to minus b. Okay, I'm splitting. See, if you have usually done from this step to this step, from down to up you go, that a है minus a common है, तो हम सिर्फ कहते हैं okay fine x raised to a minus a. But here we are doing the other way round. Okay, that is equal to, no, now that is equal to plus 1 upon x raised to b into x raised to minus b plus x raised to b into x raised to minus a. Now try to understand over here what happens. Why are we doing this? We are actually trying to factorize it. Here we see x raised to a and x raised to a is common over here. So we say 1 upon, this common factor we remove, x raised to a common factor into x raised to minus a plus x raised to minus b. Similarly over here we have x raised to b and x raised to b as a common factor. So we bring that common factor out, x raised to b into x raised to minus b into x raised to minus a. Now children, try to look at the bigger picture. What's the bigger picture? We can factorize this also further. Why? Because we have this whole thing as our common factor. See, x raised to minus a, x raised to minus a, x raised to minus b, x raised to minus b. We have this whole thing as our common factor. So what do? We say that is equal to 1 upon x raised to minus a plus x raised to minus b into into what? Into 1 upon x raised to a plus 1 upon x raised to b. This thing we have removed it outside. This common factor we removed it outside. तो बचा क्या? 1 upon x raised to a plus 1 upon x raised to b. This is what is left. 1 upon x raised to a plus 1 upon x raised to b. This was the leftover, and that leftover we have brought over here. So let's continue. That is equal to, what is that equal to? 1 upon x raised to minus a plus x raised to minus b. And here we can actually do reciprocal, don't you think? We can do the reciprocal. We can say that is equal to into x raised to minus a plus x raised to minus b. इसका भी हम reciprocal कर सकते हैं. What happens now? Yes. Here we get ting. We get our cancellations. We can simplify them. And when we simplify them, what is left? That is equal to 1, which is equal to RHS. Hence, proved. Finally. Yippee. Okay, so let's move ahead to the next question. I hope you've understood. If not, please recap and watch again. Moving ahead to the next sub-question, which is not the sub-question, the main question. Okay, here we have to find the values of n. Question 13, find the values of n. First one, what is it saying? 12 raised to minus 5 into 12 raised to 2n plus 1 is equal to 12 raised to 13 divided by, what do we have here? Divided by 12 raised to 7. Okay, what do we do here? That is equal to, this implies that no equal to sign will come here. There is already one equal to sign here. So this implies that 12 raised to common basis minus 5 plus 2n plus 1 is equal to 12 raised to 13 minus 7. Common basis but division happening. That's equal to, or this implies that 12 raised to minus 5 plus 1 will give me 2n minus 4 is equal to 12 raised to 13 minus 7 gives me 6. So I have here. Now if you notice, since the bases are common, we will say since the base are common, therefore, what happens therefore? We can say that the powers are equal because there is an equal to sign. So we can say 2n minus 4 is equal to 6. Now what happens? We can say 2n is equal to, this is an algebraic equation. So we have 6 plus 4. Therefore 2n is equal to 10. Therefore n is equal to 10 divided by 2, and that's equal to, n is equal to 5. So we have the value of n as 5. Let's move to the next sub-question, which says, question 2, what is the value of n over here? Okay, this looks a little different than the previous one. We have a raised to 2n minus 3 into a raised to 2n plus 2 upon a raised to 4 the whole raised to minus 3. Okay. Now this is equal to a raised to 3 the whole raised to 3 divided by a raised to 6 the whole raised to minus 3. Chalo, let's move ahead. That's equal to, over here we have common bases a, so we can add the powers. We can say a raised to 2n minus 3 plus 2n plus 2 upon a raised to, multiply the powers, minus 12 is equal to a raised to 3 into 3 9 divided by a raised to 6 into minus 3 minus 18. Now what happens? That's equal to a raised to, what are we going to do? Oh, not equal to sign, again I go. Common mistake we all make, not equal to sign. This implies that. This implies that what is going to happen here? We say a raised to 2n minus 3 plus 2n plus 2, and since this is dividing, this will go as minus 12 is equal to a raised to 9 minus 18. What do we get here? We get, that's equal to, or this implies that a raised to 2n plus 2n both get cancelled. How will the 2n's get cancelled? Both are positive. So we get a raised to 4n, and what we have here, minus 3n, minus 3 plus 2, we have minus 1 plus 12, so we have minus 11. That's equal to a raised to 9 plus 18 will give me 27. Further, we will say this implies that a raised to, we will not say a raised to, and we will not even say b. This implies that we will say since the base are common, therefore 4n minus 11 is equal to 27. Now children, I don't have space to do this working here, so I'm going to move this working a little to my right, and we can say over here, that's, this implies that 4n, we have 4n is equal to 27 plus 11, therefore n is equals to 27 plus 11, 27 minus 11. Yes, 27 minus 11, because we had plus over there. So this becomes minus 11, and minus 11 will give me 16. 4n is equals to 16, therefore n is equals to 16 divided by 4, which is equal to 4. My n is 4. Let's move ahead to the next question. Now we go up. Okay, let's begin with the next questions. Last question of the exercise, 14th one. Okay, but we have two sub questions here. Let's start with the first one. A raised to 2n minus 3 into a raised to 2n plus 1 into n plus 2, the whole upon a raised to 3 into the whole raised to 2n plus 1 into a raised to n into 2n plus 1. Okay, I hope I've copied the question right. That's equal to, now here first let us do the multiplication. 2 raised to n plus, not n plus, n minus 3. What am I writing? Seriously. That's equal to a raised to 2n minus 3 upon into a raised to 2n multiplied by n. Over here I'm multiplying 2n into n. I get 2n square. 2n multiplied by 2 gives me plus 4n. 1 multiplied by n gives me plus n. And 1 multiplied by 2 gives me plus 2. So n over here. A raised to 3. 3 into 2n is 6n plus 3 into a raised to 2n square plus n. Now let's move ahead. That is equal to common basis. So let's do the addition of the powers. A raised to 2n minus 3 plus 2n square plus 4n plus n plus 2. That's equal to upon a raised to 6n plus 3 plus 2n square plus n. Now what happens over here? We get that's equal to a raised to 2n plus 4n. We have common terms over here. 3 common terms. 2n plus 4n plus n will give us 7n minus 3 plus 2. Was it really minus 3? Yes. Minus 3. This will be plus 3, okay? Plus 3 plus 2 will give me plus 5. Oh, not orange, I need here. Plus 5 and plus 2n square. Okay, upon, what do we have? A raised to 6n plus n, 2 common terms over here, 7n plus 3 plus 2n square. Okay, now let's do the common basis. So we do the division part. What do we have here? That is equal to a raised to 7n plus 5 plus 2n square. Now I will take a leap over here. No, I won't take, I will write in the bracket because I don't want to confuse you all. Plus 2n square. That gives me, one extra step is better, safe than sorry. Plus 5 plus 2n square minus 7n minus 3 minus 2n square. And here the fun part again, plus 7n minus 7n plus 2n square minus 2n square, and 5 minus 3 gives me 2. So I have that's equal to a raised to 2. That's my final answer. Okay, moving ahead to the last sum of the exercise. Here we have, what is it? Okay, x raised to 2n plus 7 into x square raised to 3n plus 2 upon x raised to 4 into 2n plus 3. Now what's that equal to? Simple, first multiply the powers. x raised to 2n plus 7, भैया कुछ नहीं हो सकता, into x raised to, yes, 6n plus 4 upon x raised to 8n plus 12. Now we have three common x's, x, x, x. So you can actually add and subtract their powers simultaneously. So we say that is equal to x raised to 2n plus 7 plus 6n plus 4 minus 8n plus 12. That's equal to what? X raised to 2n plus 6n is 8n. 7n plus 4 is plus 11 minus 8n minus 12. So that's equal to x raised to 8n minus 8n. कुछ भी नहीं होता. And plus 11 minus 12 is minus 1. So this we can write as a positive index as 1 upon x raised to 1 लिखो नहीं लिखो, same thing. Hope you understood the concept. Any comment please mention in the comment section, and if you want me to make any other video of any particular exercise, do let me know. All the best and take care.